What's up, guys? This is Waleed. Today's problem is taking apart an alpha particle. So this problem took me a while to understand because there's like some concept I need to figure and understand. So when they tell us in here that, well, first let me explain the problem. We have an alpha particle, so it contains 2 neutrons, 2 protons, and we need to take them apart. We need to find the energy required to remove them each one step by step. So before we start, they gave us the atomic masses. Okay, they gave us the atomic masses. They gave us the atomic masses. So the difference between atomic mass and nuclear mass, atomic mass is equal to protons and electrons and neutron in the atom, and nuclear mass is only protons and neutrons. Okay, so we need to distinguish between those two. So in the first problem, what is the energy required to remove the first proton? So what is the energy required to go from here to this guy right here? Okay, so what we need to find the delta mass, because the sum of the particles before they were one piece, the sum of them is less than each one of them individual. Okay, so let's say that the proton weighs 1 atomic mass and the neutron weighs 1 atomic mass. The sum of them will be less, so like let's say 1.999. So difference in mass is what we're going to use to find the energy. Okay, let me open up. Alright, so the first thing we're going to do is we're going to take off the electron from, so 4 He, and this one has 2 protons. That means because it has no charge, that means that there's 2 electrons in it. So that means this one is equal to He 4 2 plus 2 plus 2 electron. So if we take 2 electron from this guy, it will be charged plus 2, positive 2. Okay, so in order for us to find this guy, we're gonna minus from helium 4 2 electrons. So helium 4's mass is 4.0026 minus 2 times 0.000548. So that's the mass of the electron. So 4e2 plus 2, this one was equal to 4.001504. Okay, so now we need to find this guy in here. So we're going to do the same thing. H1 is equal to 3 1 plus 1 plus 1 electron. Okay, that's the summate, like, so 4 He is going to be equal to, this is plus 2 is going to be equal to 3 1 plus 1 plus proton, because they're asking about the first proton that we're going to remove from the equation, from the mass. So for this guy, we're going to do 3.01605 minus 0.000548. And this one we have 1 electron because in this guy in here we have only 1 proton. So, and it's electric, we need it to be what do you call it? We need to be no charge on it. So when we take electron from it, it's going to have a positive charge. I wouldn't confuse you with this. So the answer for this guy was, so for 3h1 plus 1 is going to be equal to 3.015502. Sounds good. So from here we can find the mass. So we find this guy for this equation, and we know the mass of proton. So let me plug in this in here. So what we have is 3. Let me clear that up. Actually, let me plug it in here. So the summation of this guy plus the proton, which is 1.00728. Okay, that's the mass of proton, minus the mass of the helium-4, which is 4.001504. The mass of the helium without the 2 electron, because we're looking at the nuclear mass. Okay. My phone keeps turning off. I have all the solution on it so I don't get lost. So from here we find that the delta M is going to be equal to 0.021278. Okay. And then E, the energy, is equal to delta M, and they want an milli electron volt. So we just multiply delta M times 931.5 electron volt. And for this I got 19.82 milli electron volt. Okay. Alright, so we got it done with this one. Now what's the energy required to remove the first neutron? I'm just going to go with the numbers with you guys. So for this guy, let me separate this. So I'll write it on here. So for this, delta M is going to be equal to 1.00867 plus 2.0141, and then minus electron 0.00548 point minus 3.015502. Okay. So after you find that mass, you multiply it times 9.93. Multiply this times 931.5, and this will equal to 6.259 milli electron volt. Cool. Now for number 3, we got what's the energy required to separate the remaining neutron and proton. So what we're going to do is, so 2H1 is going to be equal to 2H, 2, 1 plus 1 plus E, same thing I did before. So we're going to do is 2.0141 minus 0.000548. This will give us that it's equal to 2.013552. That's the 2, 1 plus 1 without the electron. We're looking at nuclear mass of those guys. So now 9.31.5 times the difference in mass, which is 2.01355, and then we minus the mass of the proton, mass of the neutron. So we start with the mass of the proton minus 1.00867. Okay, and for this guy I got 2.23 milli-electron volt. Sounds good? That's for this guy. And then what's the total binding energy of the alpha particle? For this guy, you just added the answer from 1, 2, 3. So 2.23 plus 6. Where did the other one go? 6.259 plus 2 plus the 19.82. So for this one, I got 28.304. Cool. So that's the total energy. EV, MeV. Number 5, what's the total binding energy for a nucleon for the alpha particle? Per nucleon. So we have 4 of them. We have 2 proton and plus 2 neutron. Okay. So we just divide them. So 28.304 divided by 4, which gave me around, I think, 7.07 MeV. Cool. Alright guys, hope this helped. Hope I didn't confuse you with anything, and good luck. Bye.